Welcome to this explainer. Okay, today we're tackling something every JavaScript developer has to deal with at some point. We're going to build up your developer toolkit by mastering one of the most essential and honestly sometimes most confusing features in JavaScript, the date object. Whether you're displaying current times on a sleek modern blog or calculating future events in a massive web app, time management is a skill you absolutely need to lock down.
Okay, let's dive right into this. We're going to start by meeting the date object. Look at how to build your own dates, navigate some of JavaScript's infamous calendar quirks, extract time using methods, and finally, avoid a major pitfall called the date comparison trap.
So let's kick things off with section 1, meet the date object. Basically, you can think of the date object as your inbuilt time machine for JavaScript. It's the absolute fundamental building block you'll use whenever you need to handle time-based logic. It allows you to create completely dynamic dates, meaning if you want to automatically show the current updating time to your users, you can. Or if you need to lock in and store specific historical or future events, this is your go-to tool. And getting started is super simple. You just initialize a new instance by calling the new date constructor. If you just leave the parentheses empty, boom, it instantly captures the exact current date and time right from the user's system, literally down to the very second. It's completely dynamic, so you never have to worry about manually updating it yourself. Now that we've got the current time down, let's move right along to section 2, building your own dates. So, remember that time machine analogy I mentioned? Well, you aren't stuck in the present. By passing specific arguments into that constructor, you can jump literally anywhere you want on the timeline. You can jump way back to a random date, like December 2nd, 1545. Or you can fast forward way into the future, like January 31st, 2515. You just feed it the year, month, and day. And if you need to be incredibly precise, the exact hours, minutes, and seconds. But hold on, before we get too crazy with time travel, we need to cover section 3, JavaScript's calendar quirks. Now, what's really interesting here is the acceptable range for these parameters. For time, JavaScript uses a strict 24-hour clock. So if you pass in a 10, that's 10 a.m. A 22 is 10 p.m. Makes sense, right? Minutes and seconds run 0 to 59. But take a really close look at the accepted values for the month. See anything slightly weird there? Yep, the number 0. In JavaScript, months are 0 indexed, meaning the number 0 actually represents the very first month of the year, January. So if you're trying to set a date for December, you don't type 12, you have to pass through the number 11. It feels totally absurd at first, but it is deeply baked right into the language. So here is the crucial takeaway. You've got to separate how months and days behave in your head. Months are 0 indexed and run from 0 to 11. But the days of the month, those follow standard formatting. They start at 1 and go to 31. Honestly, mixing up a 0-indexed month with a 1-indexed day is practically a rite of passage for new developers. Lock this quirk in your mental toolkit right now. Okay, dates built. Let's move to section 4, extracting time with methods. Once you've got a date object stored in a variable, you get access to this whole menu of built-in methods to pull out exact pieces of data. Say we have a birthday stored, January 15th, 1985. You can use getFullYear to grab that 4-digit year, 1985. Calling getMonth will give you a 0 because, again, January is 0. And getDate pulls the actual day of the month, which is the 15th. But check this out. One of my absolute favorite methods is getDay. Notice it's different from getDate. What getDay does is it actually calculates the day of the week you were born on. It runs the math behind the scenes and kicks back a number from 0 to 6, where 0 equals Sunday. So for that 1985 birthday, it returns a 2, which perfectly works out to a Tuesday. Pretty cool, right? All right, this brings us to section 5, the date comparison trap. We are flying through this, but listen up because this is a massive pitfall that catches almost everyone. So picture this. You've got two people. You create a date variable for person 1 and a date variable for person 2. They are born in the exact same year, month, day, hour, minute, and second. They are completely identical. But when you write a basic if statement in JavaScript to ask if birthday 1 equals birthday 2, JavaScript tells you they aren't equal. Wait, what? Why on earth would that happen? Here is the aha moment. When you do a standard equality check, JavaScript isn't actually looking at the intrinsic calendar dates you typed in. Because you called that new date constructor twice, JavaScript created two completely separate objects in the computer's memory.
Even though the contents match perfectly, the code just sees object A and object B and concludes, nope, not the exact same object. And this brilliantly illustrates the workaround. If you just check if the two date objects are equal, that intuitive approach flat out fails. But we can use our magic weapon, the getTime method. If we attach getTime to both of our birthday objects, suddenly the comparison works perfectly. But what exactly is getTime doing behind the scenes?
Well, when you call getTime, you don't get a standard date format back. You get a massive number. It literally converts the date into the total number of milliseconds that have elapsed since a very specific moment in computer history, January 1st, 1970. By turning both dates into this completely numerical millisecond value, JavaScript stops comparing two different memory objects and starts comparing two identical numbers. And numbers, those can easily and reliably be compared.
It's kind of wild to think about, isn't it? Nailing down these basics, handling the zero-index months, knowing when to deploy getTime, it's the absolute foundation for building solid, dynamic, time-aware web apps. So I'll leave you with this to ponder. The next time you're using a beautifully designed, super slick web application, do you hear it? Underneath it all, that clock quietly ticking away the milliseconds since January 1st, 1970? Keep learning, keep building, and I'll chat you in the next explainer.